Oh, what'd you say, number 7, was it?
Yeah.
Okay. Number 7, just so you know, actually we did that same one in your notes. Okay. So please make sure you are using your notes as reference. The reason we did all those examples is so you could use them. But I'll go over number 7. Number 7. Okay, no, we can do 7. That's fine. Our general strategy here is I see a log on one side and a number on the other side. So I want to get to the point where I can rewrite this as an exponent. Okay, anytime you have just one log, I would try to get to the point where you can write it as an exponent. But I'm going to have to get rid of any stray numbers around that log. So what number do you want to get rid of?
10.
Okay, so this is negative 10. Let's add 10 to each side. So log base 4 of x plus 3 is now equal to 0. All right, so now that I have just log equals a number, I'm going to rewrite as an exponent. What would this look like in exponential form? Yep, 4 to the power of 0 is equal to x plus 3. Okay, 4 to the power of 0 does equal 1, yep. So 1 equals x plus 3, and then from there you could just minus 3, you get negative 2 equals x. Okay. Anything else on the front side of this page you want to talk about? D? 4? Okay. So number 4 says 5 times 6 to the power of 3x equals 20. All right. So again, my strategy for something like this, when I have the x up in the exponent, I would try taking the log of both sides, because that's going to let me do what I did in that last problem of the warm-up. It's going to let me shift the variable down in front so I can work with it. But I need to get rid of any numbers on the outside of the exponential. So what number do you want to get rid of in number 4?
5.
The 5. So let's divide by 5. And that's going to give me 6 to the power of 3x equals 4. And that's exactly what I want to see, is I want to see something to the power of x equals a number. Okay? No other numbers floating around there. Now when I'm at this point, I can't go any further without dealing with that x up in the exponent. Jotea, what do you think?
Oh, I must have did it wrong. Because I did the log 4 divided by log 6.
Okay, that's going to work. Here's where that came from. Is if you take the log of each side, and then move this exponent down in front of the log.
Yeah, sorry.
Okay, so it would end up saying 3x times the log of 6 is equal to the log of 4. And some people said they wanted to divide by 3 at this point, which actually could work. Okay, you could divide by 3 right now. I would get rid of the log 6 first, just because I like to get those logs out of the way. So divide by log 6, divide by log 6. Okay. 3x equals, can someone do this division for me?
0.773.
Okay, 0.773. And then divide by 3. 0.774? Oh, if it rounds, you mean? Yeah. Okay.
And then you get 0.258.
258. I wasn't real specific about where I wanted you to round, so if you're close to that, you're probably fine. Okay, Kara? 6? Okay. So number 6, again, I'm in a situation where I have a single log and a number on the other side. So I want to be able to write it as an exponent. But first I need to get rid of the negative 2. How am I going to get rid of that? Okay, this is multiplication. This is negative 2 times that log. So I need to divide to get rid of it. Okay, so log base 3 of 5x is equal to 2. How would I write that as an exponent? Which number is the base? 3. And then you would go to the power of 2. This is always your exponent. And that's going to equal 5x. Well, that's what, a log is just a notation for an exponent. And when I say log let me give you an example here. When I say log base 3 of 9, log is just an abbreviation for exponent. What I'm asking is what exponent would it take to turn a 3 into a 9? What power would you raise 3 to make it turn into a 9? 2, right? 3 to the power of 2 is 9. So log base 3 of 9 is 2. Okay? What this is saying is 3 to the power of 2 is equal to 9. So the log is just notation. It's not like a mathematical quantity. All right? It's just a notation for an exponent. Isaac?
So why even make another way to write it?
They make that other way to write it so that you can bring those exponents down and work with them. So you can really just examine the exponents themselves. Because when they're
like a research type of thing?
kinda like it lets you do more things mathematically. Okay. Really, what it does is it gives you the inverse of an exponential function, so that you can look at just the exponent as opposed to looking at the other quantities. Okay.
Is there still mathematical equations being made today?
Oh, sure. Yeah, I'm sure there would be. Okay, let's go back to, where was I? Sorry. Number 6 is what I was working on. Sorry, I couldn't find where I wasn't finished. All right, 3 squared is 9. So now I have 9 equals 5x. And then what would I do from there? Just divide by 5, right? Yep. X is equal to 1.8. Okay. I was just going to say, let's head to the back. So number 10. Now number 10, I've got 2 logs that are equal to each other. And I don't have any other numbers floating around, right? I don't have any numbers there that are not already attached to a log. Okay? So that's going to make life really easy for me. Jotea, what do you think?
I just had a quick question
Sure.
for 9. Is the answer 6?
Mm-hmm. Yep. Here's why. If you look at number 10, I'm going to do the same thing. In number 10, if I have log base 5 of something equals log base 5 of something, what do you know about the two somethings?
They're the same.
They have to be the same thing, right? So then I can say, let's get rid of the logs, and I know 4x must equal x minus 3. Now what surprised me on this one is the people I was helping with, they knew what to do with the logs, they didn't know what to do with this. Subtract what?
Plus 3.
Okay, here's the problem. With the plus 3, if I were to add 3 over here, can I combine 4x and 3? No. So that's right. That's not going to get me anywhere. But I can minus the x. Isaac?
That actually had me staring at the paper for like 2 minutes straight.
Yeah,
and then
this
I
is,
realized.
I saw that with a lot of people. Like they got here and just lost their minds. Okay? Here, if you're trying to get x by itself, you've got to get the x's together somehow. So, and I really think if there had been another number over here with the 4x, that you would have been okay. But I'm going to start by moving this x over. What is 4x minus x? It's 3x. It is not 4.
Would that make the 3 negative 3?
Yes. I see that all the time. People say 4x minus x is 4 because they just they figure that if you're taking away the x, then the x is gone off the 4. Okay? But that's not what this is. This is 4x minus 1x is 3x. Okay? Divide by 3. Divide by 3. X is equal to negative 1. Okay? What else you want to see? Cassidy? 15? Okay. Now 15, actually this is a great segue from part 3 to part 4 here. 15, do you notice that everything in my problem is a log? Okay, I don't have any numbers in number 15 that are not attached to logs. But I have more than 2 logs. So what I'm going to need to do is I'm going to need to condense it. I'm going to need to put some logs together. And you can do that using those properties we've talked about. I forget. Am I doing 15 or 16? 15? Okay. So 15, I'm going to take these logs and combine them. The 2 that are on the left side of the equation together. This is subtraction. So what does that mean I'm going to do with these 2 things? Yeah, I'm going to divide. So this is going to come out saying this. Log base 6 of x plus 1 divided by this x here is equal to log base 629. Now I have log equals log, so what can I do? Get your logs out of there, yep. So now I have x plus 1 over x equals 29. Now this one is weird to solve, okay? You know how to do it, you have all the tools you need to do it, but it is a weird one. You cannot, nope, because this x is attached to a 1, okay? So you can't cancel it out unless you have an x plus 1 to cancel it with. What do you think? D? No? D? Nope. Okay, Colvin, what were you saying?
I was saying multiply by
You could, but it's going to be just as messy when you're done with that. Dominic, what did you say? Okay, if this were like a 5 down here, wouldn't you start by multiplying by 5 to get rid of that fraction? So let's multiply by x. Multiply by x here, multiply by x here. Cancel those out. So now I have x plus 1 equals 29x. Nope. Subtract the x. So I'm going to get 1 equals 28x.
128.
It is, yep. Then I would divide by 28. You could make that a decimal if you wanted to. Probably cleaner to just make the answer 1 over 28. What's wrong?
How did you get 28?
29x minus 1x is 28x.
Oh, and then why'd you divide by 28?
Because I'm trying to get x by itself. There's a 28 in front of the x, so I'm going to divide by the 28. If that were like 5x equals 10, I would divide both sides by 5, right? That's 28x times what? I'm sorry, that's 28 times x equals 1. So I would divide by 28. Okay? Like 5 point something? Okay. 13, yep. So 13 again, I've got 2 logs here equal to another log over here. So I would combine these two. So what's that going to look like when I combine them? Okay, nope, you don't have to worry about the base. Okay, you're not changing any bases. How do I combine the x and the 7? Yep, so this would be 7x. Log 7x equals log 37. The base there is actually what? 10. But it doesn't matter because what I'm about to do is get rid of those logs anyway.
Oh.
So then you would have 7x equals 37 and you would divide by 7. Okay. Yep, I would not divide by log of 7 because the log of 7 is attached with addition. I guess you could have subtracted log of 7, but I think this way is cleaner. Okay. One more. Anna. 17? Yeah, let's do one of those. I was hoping for one of those.
18.
Okay. 17. Now, in this one, the difference between these ones and these ones up above is, see how here when I consolidated, I ended up with log equals log. Here I'm also going to consolidate, but I'm going to end up with log equals number. These ones are going to end up being more like, I think it was part 2 on the other side, where you had a log equal to a number and you rewrote as exponents. That's what I'm going to do here too. I'm going to combine these. How do I combine those? It would be log of 2x. Okay, because addition means multiplication. Okay. And now I have a log equal to a number. So I'm going to rewrite this as an exponent. Okay. What's my base here?
10.
Base is 10 if it's not written. So how would I rewrite as an exponent? Yep, equals 2x. What is 10 to the power 1? Just 10. So now I have 10 equals 2x. Yep. Divide by 2, divide by 2. X equals 5.
How would you combine the log of 18?
I would put a 2 up here as an exponent to make that x squared. And then this would become 8 times x squared. So you have log base 8 of 8x squared equals 2. And then try writing it as a power. Okay? I think you can do that.